In a series circuit, if we need to find total resistance or equivalent resistance, all we need to do is add them up. So in this case, A plus 4 will give us 12. 12 ohm is the equivalent resistance for this series circuit. Now let's look at the a combined. This one is parallel with these two once they combine. Okay. So for parallel circuit, we do a little bit different. It's 1 over R1 plus 1 over R2, and then we need to flip them over to find the total resistance. So R total over some number. Okay. Okay, so in this case, 1 over 8 plus 1 over 8 is 2 over 8, which reduced to 1/4. Okay, now we need to flip it. Take the reciprocal of these two numbers. Denominator go on top, numerator go to bottom. And so in this case, we get 4 over 1, which is 4. Okay? 4 ohms is the equivalent resistance for this branch. Okay, for just that branch. Now we need to add to 8. Okay, add 8 to it, which come out to be 12 also. So 12 ohms is how we find the equivalent resistance for parallel. Next, we are going to find the current for the simple circuit. So let's start off with this one. So what's the current for this one? In order to find current, we need to know the equation, the Ohm's law. Okay, so Ohm's law states that voltage is equal to current multiplied by resistance. So resistance we know, voltage we know. We're looking for current. So if you rearrange the formula, you will get V divided by R equal I, right? So V is 60, R is 10. So 60 divided by 10 is 6. So your current is 6 for this one, the circuit. Now let's look at the next one. 20 ohms and 20 ohms, they are in parallel. In parallel, we know that we need to put them in fraction and add them up, right? So 1 over 20 plus 1 over 20. So this will give us 2 over 20, which reduced to 1 over 10. Okay, so 1 over 10, flip them over. So you get 10 ohms for that branch. Okay, once we know the total resistance, equivalent resistance, we use the same formula to find the current, and it happens to be the same number that we have. If you see a problem with a multiple resistance that are in parallel, the best way to do is to reduce them, turn them into series, so we can solve it easier. Okay, so R1 is parallel with R2. So we add them up, put them in fraction. 1 over 100 plus 1 over 250. If you do not sure how to do fraction, just put them in the decimal. Okay, so this one is 0, 1. This one will be turned into 0 0.004. Okay, once you add them up, you get an answer of 0.014. Okay, if you use in decimal, all you need to do in the next step is to take 1 divided by that decimal. So 0.014. This will give you about 71. About 71 ohms. Okay. So that's for R1 and R2. Now we will do the same for R3 and R4. Find an answer of 127. So 127 ohms. This one. Okay, and now we need to add them because once you combine R1, 2 and R3, 4 will be in parallel. I mean in series. So you take 71 plus 127. You get an answer of 198. 198 ohms is the total resistance in this circuit. Now let's find the total current. You know R, you know V. So now just plug in the equation V equal to IR. So V divided by R will give you current, right? So 24 divided by 198, 2 amps. Okay. Next, we will look at the voltage drop for these resistors. For this one, 24. When 24 goes into a parallel circuit, 24 volts will split up. However, in parallel circuit, voltage in parallel will be the same. So for this one, since the voltage goes to this one, it has not dropped anything yet. Okay, so in this case, it will still be 24. Nothing changed yet. So 24 for these two. So in this case, just 24 volts. Now we look at the 200 volt, the bottom part of the circuit. Previously, we found that R12 is 71 ohms, right? When we combine them, and we know the current. The current is 0.12 amps. Okay, so now that's all we need for this. Okay, so the combined resistance is 71. R is 71. I is 0.12. Okay, that is all we need. So we take 71 multiplied by 0.12. We get a voltage of 8.52. Okay, so after voltage go through this combined resistance, it will drop 8.52 volts. Okay? So how much left? To find how much left, you take 24. 24 subtract to this number, and you get, and that is our resistance for this, for voltage drop for this one. So if you want to check, you would do 8.52 plus 15.48. You should get the total voltage back to be 24 volt, and that is how you check voltage drop in series.